in the heart of Midtown Manhattan, where the skyline is not a backdrop but a competition. One building stands above the rest. Not merely above, impossibly above. A needle of pure glass and steel rising 1,396 feet from the pavement. A perfect square repeated 96 times until it becomes a vanishing point against the clouds. It was designed to be the most ambitious residential address on Earth. A tower so thin, so severe, so deliberately extreme that simply looking at it from the street feels like watching something that should not exist. And perhaps it was right to feel that way, because something is wrong inside that building. Not visibly wrong, not emptily wrong, the way a ghost tower is wrong, but quietly, persistently, expensively wrong, in a way that is costing its residents and its developers far more than anyone publicly admits. This is 432 Park Avenue. It cost $1.4 billion to build. Its units sold for between $16 million and $130 million apiece. And today, it is the subject of a lawsuit alleging 1,500 construction defects, a building where the mechanical rooms have flooded repeatedly, where the elevators have failed, and where residents on the upper floors describe lying awake at night listening to a skyscraper groan. Why? Because of a single design decision made before the first steel beam was lifted that placed the pursuit of profit above the demands of physics. And then, when that decision demanded engineering accommodations that cost real money to build correctly, the cheaper path was chosen. This is the story of how that one choice became the original sin of the most ambitious residential tower New York City has ever produced. This is the terrible engineering behind New York City's $1.4 billion skyscraper with a fatal design flaw. To understand what went wrong inside 432 Park Avenue, you have to understand the number 1 to 15. That is the building's slenderness ratio, its height compared to its width. For every 1 foot of width at its base, this tower rises 15 feet into the sky. The Empire State Building, one of the most recognizable structures on Earth, has a slenderness ratio of roughly 1 to 8. The Chrysler Building is similar. These proportions are not arbitrary. They represent the engineering consensus on how much height a given footprint can safely and comfortably support. 432 Park Avenue pushed that number to 1 to 15. It was, at the time of its completion, among the most extreme slenderness ratios ever achieved in a residential supertall. The reason was commercial, not architectural. The building's footprint, a 93-foot square on a single midtown block, was fixed by the land available. The only direction to grow was up. To maximize the number of luxury units, each with unobstructed sky views above the surrounding skyline, the developers needed extraordinary height from a relatively modest base. The math demanded extreme slenderness, and extreme slenderness came with a cost. At 1 to 15, the building moves. It must move. On a windy day in Midtown Manhattan, the top of 432 Park Avenue sways approximately 3 feet in each direction. This is not a defect. It is Newtonian physics operating exactly as the equations predict. The building was designed to sway. A tuned mass damper, a counterweight system installed near the building's upper floors, was engineered to oscillate against the sway and reduce the motion felt by residents. But even with that system, the building is alive in wind events in a way most buildings are not. The steel frame expands and contracts with temperature changes. At 1,396 feet, those movements are amplified enormously. Residents on the upper floors described what it sounds like to live inside this. Loud cracking sounds, deep groaning, the kind of noise that rattles furniture on calm days and makes sleep impossible during storms. The condo board's lawsuit specifically cites noise as a chronic defect, not an occasional inconvenience, but a persistent structural feature of living in a building pushed beyond the comfortable boundaries of its own slenderness. Imagine standing inside the body of a tuning fork the size of a skyscraper. Every wind event, every temperature shift, every change in pressure becomes audible. That is what the residents of 432 Park Avenue were sold, a $20 million tuning fork with views of Central Park. But the developers chose to build at 1 to 15 because it maximized the value of their land, and maximizing the slenderness required an engineering accommodation that would become the building's second, more tangible disaster. To manage the wind loads that a fully enclosed 1,396-foot tower would otherwise experience, the architects designed something into the building that sounds reasonable in a boardroom and catastrophic in a rainstorm. They put holes in it. At regular intervals, approximately every 12 stories, 432 Park Avenue stops being a sealed building and opens itself to the sky. On these floors, the curtain wall of glass and steel is replaced with large, open, square apertures. From the street, they read as a kind of visual rhythm in the facade, a deliberate accent in the architecture. From an engineering standpoint, they are something more specific. They are the building breathing. At 1 to 15 slenderness, a fully enclosed tower at this height would experience enormous lateral wind pressure across its entire surface. By opening 6 floors to the wind, allowing air to pass through the building rather than press against it, the mechanical floors reduce the overall wind load on the structure by a meaningful margin. Without them, the engineering becomes significantly harder. With them, the numbers become manageable. In theory, it is elegant, a building that accommodates the wind by simply getting out of its way. The problem is that getting out of the wind's way also means getting out of the rain's way. At the altitudes where 432 Park Avenue's mechanical floors are located, some of them 600, 700, 800 feet above street level. Horizontal rain is not a weather event. It is a routine condition. Wind-driven precipitation at those heights arrives with a force that ground-level waterproofing standards do not anticipate. The mechanical equipment sitting behind those open apertures, including pumps, electrical systems, and elevator machinery, requires protection engineered specifically for that exposure. According to the condo board's lawsuit, that protection was inadequate. The drainage systems installed behind the mechanical floor openings were insufficient for the actual weather conditions encountered by a midtown supertall. New York City receives 46 inches of precipitation annually. In storm conditions at altitude, that precipitation does not fall straight down. It arrives sideways. And when the drainage cannot handle what the weather delivers, the water goes somewhere else. It goes into the mechanical rooms. The lawsuit documents repeated flooding events, not a single catastrophic incident, but recurring, systemic water intrusion. Pumps were damaged. Electrical systems were compromised. The building's service elevator, the infrastructure that makes a 96-floor residential tower function as a place people can actually live in, was repeatedly taken offline by water infiltration into its drive systems. Residents waited days for elevator service. Furniture deliveries became impossible. Contractors were unable to reach upper floors for repairs. This was a recurrent failure that undermined daily life. It is the engineering equivalent of designing your house with intentional gaps in the walls at regular intervals and being surprised when the rain comes in sideways. The gaps were required. The protection for what was behind them was not adequately funded. The distance between the waterproofing specification that was installed and the specification that adequate engineering required represents, in a $1.4 billion project, a fraction of the total budget. It is the rounding error that became the ROT. But even with the lawsuit filed and the defects cataloged, the building has not been comprehensively repaired. And the reason why is the most important part of this story. Let's do the math. The engineering solution to 432 Park Avenue's mechanical floor failures is not exotic. Upgraded waterproofing, expanded drainage, replacement of damaged equipment, remediation of the elevator systems. These are solvable problems. The expertise exists. The contractors exist. The materials exist. So why has it not been done? Because when you calculate the true cost of comprehensive repair across 1,500 documented defects in a 96-floor supertall, and then calculate what that repair buys you in market value, the math stops working. The condo board's lawsuit seeks $125 million from the developers. That figure represents a portion of the documented damage, not a full accounting of what comprehensive remediation across the entire building would cost. And fixing the building, even assuming the legal dispute resolved tomorrow, would take years. During those years, residents live inside the construction. During those years, the building's reputation, already public knowledge to every real estate attorney and lender in Manhattan, continues to calcify. A buyer considering a unit in 432 Park Avenue today does not simply evaluate the apartment. They evaluate the building. They evaluate the lawsuit. They evaluate who is paying for repairs and when. Their lender evaluates all of these things. Their insurer evaluates them. Every party in the transaction has access to the same public information the condo board put into a court filing. This building, which sold units for between $16 million and $130 million, has 1,500 documented defects and a $125 million active lawsuit attached to it. The penthouse at 432 Park Avenue was listed at $130 million at the building's peak, the most expensive apartment ever offered for sale in the United States at the time. After the public disclosure of the building's defects, it was repriced, and it sat waiting. It became a symbol of the building's broader economic collapse, not because the tower is empty, but because the premium that justified every dollar of the $1.4 billion development has been permanently eroded. The legal war between the developers and the condo board has frozen comprehensive action. Each side points to the other. Contractors point to designers, designers point to developers, and developers point to contractors. While the arguments continue, the mechanical floors remain. The equipment ages. Water enters when storms arrive. Residents in apartments that cost more than most American families will earn in a lifetime lie awake on storm nights, listening to a $1.4 billion building talk to itself in the wind. Unlike 161 Maiden Lane, which at least has the honesty to sit completely empty, 432 Park Avenue is occupied. The disaster is hidden inside a building that functions, partially on most days. That invisibility is its own kind of engineering crime. So what was the terrible engineering behind New York City's $1.4 billion skyscraper? It was not simply inadequate waterproofing. It was not simply an aggressive slenderness ratio. It was not simply a drainage system specified below the requirements of the weather it would face. Each of those failures is real and documented, but they are symptoms of something larger. It was the belief that a building could be pushed to the absolute physical limit of what engineering will permit, a 1,396-foot tower on a 93-foot base, and that the accommodations required to make that building safe, livable, and durable could be treated as line items to be minimized rather than as the load-bearing core of the entire project's survivability. It was the decision to optimize for the number that appears on the sales sheet, the height, the views, the prestige, while underfunding the engineering that makes height, views, and prestige survivable. 432 Park Avenue stands today not as a ghost tower, but as something arguably more disturbing. It is a monument to failure that is still lit at night. People sleep inside it. They wake up to some of the most expensive views in the Western Hemisphere, in apartments purchased on the promise that nothing like this could happen in a building like this. That promise was made before the first steel was lifted. It was broken in the same moment. And in a city that has always treated the skyline as a statement, 432 Park Avenue is the reminder that the higher you build on a foundation of shortcuts, the further you have to fall.